Thanks, Vicky, and hello. Appreciate you taking the time out of your busy days. My name's Wallace, on behalf of Innovos here today, and thought we'd run this session today here, National Clean Air Day, so thought it might be appropriate to share some of the work we've been doing with the NHS on air purification and the work we've been doing since 2007 really as a company. I guess if we just take a step back to 2007 when Innovos first started out, we've really been, ultimate vision has been to eliminate any opportunity for patients to acquire an infection whilst in hospital, and that's really been the basis of all we do and is at the heart of all that we're doing as a company. And we know that from our work with hospitals that really we've boiled it down to what we call the four main vectors, and that's really to simplify our approach to controlling the infections in hospitals. So just running through those briefly, we know that people are obviously a vector in hospitals and they can affect the transmission of infection. We have water that can cause cross-contamination. We then have surfaces, and that's really been at the heart of what we've done since 2007. So behind me today, I've got the UVC and the HPV decontamination technologies. So that's really addressing the challenges with surface contamination and reducing the risk from that. And then lastly, we have air, which we know from the last 2 years, particularly with COVID being a infection, a virus that's transmitted via air, we know that there's been a lot more emphasis placed around that, and we know that there's a lot more there's emphasis placed on that, and we know how important it is that we're controlling that vector. Obviously, COVID being transmitted via droplets in the air, and we've really developed a suite of technologies to help reduce the risk of airborne transmission of infection and support the control of that in healthcare and in hospital estate. So I thought it might be beneficial just to run through. I've got two systems next to me here today. I thought it might be beneficial to run through these two systems just as a bit of an overview of the systems we've been working with hospitals, with the NHS, to control the risk of airborne transmission of infection. And just looking at air purification as a technology from a broader perspective, we know that essentially what it's doing is it's a solution to clean the air in an environment. So whether that's a clinical or a non-clinical environment, it's essentially cleaning the air. So it's not changing the air in that environment. It's simply what's commonly called is air scrubbing. So it's cleaning the air in that environment and reducing the risk from the bioburden that there might be in that area. So I guess if we run through the two systems I've got here today, there's slightly different technologies in each of those, and we'll just run through very briefly what they are and how they work, and really the basics on how they're working when we deploy them to the hospital or to the environment that we'll be working with these in. So just on the far side over here, we've got what we call the HEPA-800 air purification system, and then on this side here we have the Combi-1200 air purification system. So I guess just before we run into those, there's two main technologies we know with air purification. There's HEPA and there's UVC. They're some of the most common technologies that we're seeing. And the HEPA-800 system incorporates 4-stage filtration, with the main feature being the HEPA filtration in that. So that's H13 HEPA filtration. We then have the Combi-1200, which incorporates both HEPA and UVC sterilisation. So that's five-stage filtration in total. So I guess just as a bit of an overview of the HEPA-800 system, essentially what it's doing when we deploy it into an area, it's drawing the air in the side of the system before it goes through those 4 stages within the system, and then it's generated back into the room. So on both sides of this system here, we have an intake, and if we just open it up, it might be beneficial. We essentially have a pre-filter first, which is just filtering out the large particles in the air. So that's really essentially the first stage of filtration. Before it then goes behind that, we have the HEPA and carbon filtration, which is a combined module, which is removing the finer particles in that room. So we know that we've got H13 filtration, and that's removing the particles in that area. And then there's also incorporated in that is the carbon filtration. So that's removing the odours, any what you might call smells or in that area, before it then passes through an ionisation module and is then discharged back into the clinical area. So that's a very brief overview of the system here. I mean, I guess just a few other points around the physicalities of the system. Essentially, we've got a simple display control on the top of the system, which is how we're controlling the system, and it really makes it easy for anyone to deploy that technology. And it's just powered by a simple 3-pin plug, and we can deploy that anywhere where there's power, and we would simply what we might call plug and play. There's a control on the top where we can power it on. There's a number of different fan speeds, obviously anything up to 800 meters cubed per hour. It also has an auto fan speed setting, which is just adjusting according to the burden in that room. So that's adjusting the fan speed according to the environment that it's deployed in. There's also a number of other features, including a safety or a child lock, just to ensure that any patients or anyone else in that area isn't meddling with the system unnecessarily. So I guess overall, it's a simple technology that can be rapidly deployed into areas where there might be higher risks of transmission of infection via the air, and we can deploy that into an area. It's a flexible solution, so we know we can move it. It's a portable system, so we can move it around the estate, and we can deploy that in areas where there's requirements, which is really similar to the Combi-1200. So as with the HEPA-800 system, the Combi-1200 is also a portable, a mobile system using the same plug and play concept, we might call it, to deploy that as and where there is a requirement. It does incorporate UV sterilisation though, so we know that in total it's got a 5-stage filtration process. So as with the other system, the air is drawn in from the bottom of the system before it goes up through a range of filters, and it's then discharged back into the air after it's been cleaned or filtered. So if we just simply run through the filters we have in this system, working from the bottom up, so the air is drawn in the bottom, there's the pre-filter. We then have the UV sterilisation module before we then have HEPA, H13 filtration. That can also be upgraded to H14 filtration, so we know that there's differences with the different filters we have as to the particles that they filter out. Then in the centre of the system we have the motor, which is moving the clean air through the system. We have a carbon filter at the top before it is then dispersed back into the room. When we take the panel off the back of the system, you'll hear that the system makes an audible noise, which is really a safety feature just to ensure that we're aware that the system isn't in use and that it's been powered off because the filter has been replaced. So that ensures that the system doesn't operate whilst any of the cassettes or any of the filters in that system are removed. And we can see, if we just take the top of this panel off here, we can see that the filters are simple cassettes which can be removed and replaced as required. So that enables us to easily replace the filters in the system. The system will automatically power off when those covers are taken off, so that's a safety feature to ensure that it's not operating. And then, as with the other system, we have a control panel which is giving us visibility on the use of the system. As with the other system, it does have a number of key features on that, allowing us to lock the system, to reduce to remove the chance of anyone changing the settings or the mode on that, we can turn the UVC disinfection module on or off as required. However, we'd strongly recommend that is left on. There's a number of different fan speeds as with the other system, and there is also an auto setting which is according to the environment that it's deployed into. It also has some visibility on the front of the fan speed and the airflow that we're achieving through that system. One other thing to point, and I don't unfortunately have one with me here today, but we have re-engineered this Combi-1200 system into a ceiling mounted system. And where we're seeing that brings benefits is with reducing the requirement to take up floor space. It's obviously not such a flexible solution in that it needs to be installed into an environment, but we are seeing that is a slightly longer term solution that's bringing benefits if it can be fitted into the ceiling void of a room, and it's using the same combined HEPA and UVC sterilisation and filtration to filter the air in that room without causing any obstruction, or we know obviously in a busy ward or in a cluttered hospital environment, there may be challenges with deploying this mobile air filtration technology. So that's really where we've re-engineered that into a ceiling mounted system. I guess that's a very brief overview and a bit of a summary of some of the work we've been doing, Vicky, and I'm not sure whether there's been any questions come in while we've been talking.
Thanks, Wallace. I think that was really good. We've had a couple of questions that have been sent in ahead of the webinar. The first one we've got on here is, does the positioning in the room affect the effectiveness of the systems?
Yeah, that's a good question, Vicky, and one that obviously we know that the effect of these can be impacted by the positioning of them. Obviously, if we do put them in the far corner of a room and that they're cluttered around them and that there's no access for free airflow into the system, it is going to affect the operation of the system. I think it needs to be taken on a case-by-case basis, really, and happy to, if there are any specific requirements or specific areas that there might be concerns around, then we can certainly support in looking in those areas. However, essentially, we're looking for areas in the room where the system can be placed and it's not going to obstruct the movement in that area. So if it needs to be out of the main walkways and the key areas where there'll be movement and equipment placed, but we also want to ensure that they're evenly placed around the room to maximise the chance for that full airflow around the environment. Obviously, they are mobile systems, so we can be flexible in our approach when we're deploying them.
Great, thank you. Another one that's come through is, how do you ensure that the contaminant in the filters doesn't escape back into the environment when changing the filters?
Yeah, that's another really good question, and one that you do need to be aware of. Obviously, once the systems have been using, it doesn't take long in a hospital environment, a busy hospital ward, for example, there is a lot of contaminant in the air if there's a lack of mechanical ventilation. And what needs to be done is to take care. Essentially, it's ideal and strongly recommended that we remove the equipment from the clinical area, from the area before we're changing any of the filters. And there's standard operating procedures that we can share as on how is best recommended that we replace those filters outside of the clinical area.
Great, thank you. Another one is, do they measure CO2 levels and humidity?
That's a good question, and it's something which on these systems they're still being deployed and it's a still relatively new technology. We're not actively measuring the CO2 or the humidity levels on these systems. However, we can support with external devices, and that's what we're seeing is that there's a combination in a number of different technologies just to support the implementation of the systems and monitoring that alongside that. I think that should cover that point.
Yeah, I think so. And last one that I've got is how do I work out the number of air changes or CADR in a room?
Yeah, it's a key thing to measure, and we know with air purification that's one of the key factors that affects it affects the efficacy and the and how successful we are when we deploy the technology. Essentially, we're taking the volumetrics of the room and we're considering the clean air delivery rate or the airflow of the system, and we're using that to calculate the number of systems that we require to get different levels of clean air being delivered back into the room. So that can be done simply by just taking the volumetrics of the room, and it's something that we can easily support with, and taking the airflow from the system, the clean air delivery rate from the system, and calculating the air changes or the equivalent air changes we'll be achieving in that area.
Great, thank you. Well, that's the last one that I've got. So I think if there's no other questions, then I think we're about finished.
Okay. Has there been any more questions come through while we've been talking, or any others that come up?
I haven't got anything else on here. So I think probably just say thank you to everyone for joining.
Yeah, no, I appreciate everyone joining, and really just a very brief summary of what we've been doing, and the suite of products we've developed. Obviously, there's further conversations, and it depends on from case to case how these might be implemented and the impacts and the benefits that they may bring. But I really appreciate everyone taking the time today. Obviously, it's National Clean Air Day, so we thought it'd be good to share some of the work we've been doing. And if there are any further questions, I'm sure the team would be happy to help out and answer them afterwards. Appreciate everyone joining. Thanks very much.